A car is travelling at a speed of 20 meters per second along a straight horizontal road. The driver applies the brakes and a constant braking force acts on the car until it comes to rest. Assume that no other horizontal forces act on the car. After the car has travelled 75 meters, its speed has reduced to 10 meters per second. Find the acceleration of the car. Find the time taken for the speed of the car to reduce from 20 meters per second to 0. Part C. Given that the mass of the car is 1400 kilograms, find the magnitude of the constant braking force. So let's have a look at this then. So it's 1400 kilograms, isn't it? I've summarized the question here in pictorial form then. Part A. The acceleration here then from 20 to 10 and a distance of 75. So this is the final velocity, this is the initial velocity, and this is the distance. So we can use the formula v squared equals u squared plus 2as, can't we? So v is 10, so that's 100. 10 squared is 100, is equal to u squared. 20 squared is 400. Plus 2 times the acceleration, which we don't know, times the distance 75. So here, what have we got then? We've got move the 400 over here to minus 400. 100 take away 400 is minus 300. And 275, so 150. Lots of A. So that tells us then, move the 150 from times down to divide. 300 over 150 is 2. So it's minus 2. So the acceleration is minus 2 meters per second. As units. So that's what we've got there then. Now the next thing is to find t, the total time here when it got down to 0. We now know the acceleration. We know the final velocity is 0. So the formula here is v equals u plus at. So v is 0. The initial velocity is 20. The acceleration is minus 2. And we need the total time to go from 20 down to 0, don't we? So we put that in. Move the minus 2t over to p plus 2t. Leave the 20 as is. And then move the 2 from times down to divide. 20 over 2 is 10. So t is 10 seconds. So there's the time. Part C now, the force. Well, force is the mass times the acceleration, which is minus 2. So part C, using F equals ma, gives F, the force, is equal to the mass in kilograms was 1400. The acceleration was minus 2. So we've got minus 2800. Well, the acceleration in even though it's negative, it's 2 really, isn't it? Because this is a force in newtons. So to produce that acceleration of minus 2 or 2 in the other direction, so to speak, is 2 times 1400, 2800 newtons.